Alright, ladies and gentlemen, so welcome back. Tuesday. We're going to finish up combining like terms here. So basically you have an assignment, 6 problems to take a look at. I'm going to teach you one new thing on top of the combining like terms, but hopefully I can show you an example, show you a different way to look at some stuff, but don't have a ton in this video. So I'm basically going to focus on these 2 problems. Let's start with the top one. Let's go ahead and get that out of the way for us for now. All right. So the reason I wanted to show you this one was, so yesterday we talked a little bit about some people messing this up, not realizing that if you're going to find the like terms here, that you're going to have 3 different like terms. And so the x squared terms, those are like terms. Negative 12x, it's always the sign out in front, and the positive 2x. And then the negative 4 and the 3. Now that the last 2 you probably knew, but just make sure that that x squared term, the terms, those are their own like terms. And I wanted to show you another way that you could see that. So I introduced this in the last video, but I wanted to show it again, which is the algebra tiles. I put the link here, take you out to this page, and wanted to show this again because this really helps to understand that this in red, these in red are different than the ones in green. So here's what I mean. So in red, you have x squared and 9x squared. I'm just actually I'll write this whole thing out using algebra tiles. So 1x squared. So you see these are labeled x, x squared, y squared. So x squared, right? And then negative 12x. It's gonna be a pain, but while I'm here, let me just say these are really nice. These algebra tiles for certain things, and especially with the mistake that a lot of us are making, which is to say this is the same as each of these. If you look at them, number one, obviously visually you can see they're different. One is a rectangle, one is a square. But think about this for a second. Why is this a square? It's x squared. It's funny that it's x squared, and that's not a coincidence. It's the fact that if you look at the dimensions, remember with area, we did a problem with area with the rooms, like the apartment problem. And what we saw was it was length times width, right? And when you think about x squared, it's x times x is the length and the width. Hence it's a square because both sides of the square will be the same. That's what squared means. It's to take 2 numbers that are the same, multiply them. So if the length and the width were 2, the inside would be 4, 2 squared. And each of these is a rectangle, and it's only 1 by x. So that, if you understood what I was saying, great. If not, just take away this. The x squared is different than x, right? We treat the x squared different than the x. It's different. All right. Minus 4. You can just click on these to make them minus, but essentially what you're doing is, and I'm going to line everything up, but this is the first part, right? X squared minus 12x, oops, minus 4 plus 2x, 2x, that is plus 3 plus 9x squared. All right, that should be good. I shouldn't have to switch back. So plus 3. 9x squared, okay. 2, 3. All right, so that's the only downfall with the tiles is it can take a while to build them. I would suggest using them for smaller numbers, and I would suggest using them for if you don't understand. So, okay, so now all you do then is, just like here, it's a jumble of different types of terms. Now you combine the like ones. So you can see x squared and 9x squared, we colored them in red. You add them because it's a positive, and the sign out in front plus 9. So that It's going to be 10x squared. And what's great about the tiles is you can see, you just group everything together. So in terms of the x squareds, there are 10. So we know we're right. All right, what about the next thing? So let's do the green, negative 12x plus 2x. So what do we have left? We have negative 10x. And we cannot combine those things. So let's go back to the tiles real quick. Take these two, pair them up, a minus and a plus, they disappear. So all four of these would disappear because a plus and a negative cancel each other out. So like right here, these cancel each other out. Thing here, count them up, you have negative 10x left. All right, and same thing here. Bring them up here, match a couple up. These will cancel each other out. These will cancel each other out. Go ahead and move this here, and this will cancel each other out. You have left, you're left with negative 1. If you go back to the slides, negative 4 plus 3 in blue, you have a negative 1 left. You cannot combine the 10x squared and the 10. And that's your answer. So that's in tiles. I'm not going to go back to the tiles, but that is an option. It is in Schoology there. Now, another note, that squared only goes with the x. It's saying that x is squared, not the 10. It's 10 times x squared. It's saying there are 10 x squareds. Same here, there are 10 x's. All right, so that squared only goes with the x. Do not square the number out in front. Okay. All right, now, before we go to the next example, which I'm going to now move back up so we can look at it. I do want to talk about this because now look at our example. It says 5 times 2x plus 7 minus x plus 1. Now, what you're thinking is, well, already I see some like terms. I see that the like term of 2x matches up with the negative x here. But here's the problem. You can't just add 2x times negative 5 because that 2x is trapped in the parentheses. Because what it's saying is that it's 5 times 2x plus 7. So it's 5 times this whole thing. So we can't combine terms until we take care of this 5. Now, let's simplify it for a second. Actually, don't know why I didn't make those exactly the same, but let's take a look at it by itself and see what this means. So 5 times 2x plus 7, what does this mean? It means that, think about what multiplication means. 5 times 1 means that you have 5 ones. 5 times this thing means that you have 5 sets of these parentheses. So this is what I mean. So that means you would have a set 2x plus 7, that's one of them. 2, 3, 4. I'll put the other one over here. So essentially these equal each other. This right here and what I have here. It's 2x plus 7 times 2x plus 7 times 2x plus 7 times 2x plus 7 times 2x. And then all you have to do is just add up how many of each thing we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10x. And then 7 plus 7, 14, 21, 5. Wait, no, I'm sorry. The answer is 35. Okay, but you can see this is annoying, right? Writing it all out, adding them up. But why don't you take a look at our answer? And this is called distribution. It's the distributive property. We're going to get more into it later, but hopefully that doesn't look completely unfamiliar to you. It should look familiar, as you did do it a little bit last year. And that is, look at this. 5 times 2x, 5 times 2 is 10. Huh. Right? And then 5 times 7 is 35. Anytime you see this, you can use the distributive property rather than writing out everything that's happening. It's a number times a set of parentheses because it's 5 times this entire thing. So you have to do that before you can combine like terms and simplify. Okay, so let's go and see that in action then. All right, so 5 times 2x plus 7, that 5 times 2x, you just take it times each of the terms, and when you do that, it's just 5 times 2, the x comes along for the ride, times 5 is 35. And then everything else, nothing else changes. Everything else behind it stays the same. And now we can combine our like terms. And you can see there are two types of like terms, 10x and negative x. And then 35 and 1. And look, look at the go ahead and look at the color of these. So like green, there are two things of green. In the end, you should have one thing of green. So 10x minus x is 9x. So what I mean is that if you have, for example, this has two types of like terms, your answer in the end should have the two types represented with one number. In this case, 10x and negative x made 9x. Now, unless they cancel, that can happen. But for the most part, you'll see 35 plus 1 is 36. You'll see we had two different colors of, or two different types of like terms. So you have two in the answer. Same thing up at the top. You had three different types of like terms. So you'll have 3 in your answer. Like I said, unless they cancel each other out, that will be true for most of these problems. All right, but you'll have to distribute first, and then you can go about, oops, wow, that was like kind of bonus circle there. Other than that, that's all I have for you. Try the problems on the worksheet and take care, guys.